Hello, everybody, and welcome to Sparring Partners. And today we have a very interesting session on MIMO. And MIMO, massive MIMO, GIGA MIMO, there is all sorts of MIMOs. And people talk a lot about, the latest, what's the latest in MIMO. But today what we're going to do is something different and I think much more interesting to sort of step out a little bit and look at the history of a technology, but also of a concept and how that help us in wireless telecoms. So we'll go from the single antenna, the basic MIMO, massive MIMO, and GIGA MIMO, which huge and continuously increasing number of antennas and way to manage them. And I have the pleasure to have with me Zhang Jiong, who is the RAM marketing director at ZTE. And Zhang Jiong and I had a lot of discussions over this. So this is going to be, get ready, a wide-ranging discussion about everything you probably have not really heard much about MIMO, or actually maybe you heard about it, but you haven't thought about it because we are all kind of caught into the latest products. So we're going to look at the bigger picture. So Zhang Jiong, welcome to Sparring Partners.
Thanks for having me. It's great to be here.
Same here. And why don't you give us a little bit of background of what is it you do today and how do you end up there?
I'm working for ZTE, especially now for 5G RAN and future technologies of cellular network. I started, in fact, the mobile industry since maybe 20 years ago, more or less. The thing is, we're using a lot of cellular network. Sometimes we know it, sometimes we don't even know it, but we're using a lot of data, and sometimes the data comes with very interesting technology behind it. So hopefully we're going to talk about this kind of technology, not just from the perspective of the industry insiders, but also from the perspective and understanding from ordinary users. Hopefully it's going to be fun.
So MIMO is a beautiful concept, right? You can just reuse frequency spectrum, but it's also a complex one, and we usually think about it from a sort of engineering technology point of view. But effectively, what we are trying to do is to communicate, to get people to talk to each other through their phones or whatever, or machines talking to each other. How should we think about it? The conceptual part, if we remove our telecoms hat, how do we think about MIMO in terms of communications among humans?
Yeah, if I can forget about telecom for a second, I would still believe communication is essential to human needs. Think of ourselves as just human beings without any technology. I mean, in its modern sense, we don't have any smartphones or cables or whatever, electronics, nothing. We could use over long distance. Maybe we can use drums. In fact, drum beating is a way of communication over long distance, like a few hundred meters. It's still happening in some tribes in Central or Western Africa. For example, you could talk to your family member far away by beating the drums. you're basically saying dinner is ready, please come home. Dinner is ready, please come home. Please come home, dinner is really ready. You're saying this over a long period of time. The repeated message is actually to make sure the other end is going to actually receiving the message very well in case of loss of the signal due to a strong wind or something. But that long duration is actually not that efficient. So this is sacrificing efficiency to guarantee reliability. So MIMO, on the other hand, is to have really great efficiency. It takes very short time, but to transmit a lot of information. So this is a very good way to do communication. Or in our case, it's to do telecommunication through cellular network or even Wi-Fi. So this is what I see from a everyday experience perspective, why MIMO matters.
Yeah, absolutely. And that's something that, I guess in wireless, we love the technology. And it's very easy to think about it in those terms, but there are people actually using it. And sometimes we kind of don't think as much as we probably should. But now let's start with MIMO. And MIMO is an interesting case because it all started in the 70s, right? But for a long time, it was clear that there was something to it. I mean, it was conceptually a solid thing, but a lot of people, I remember talking to colleagues that they would just think that there was just nothing, commercial come out of it. And so, but then it did happen. And even though even now there is still a little bit of resistance. So there is some people that are really in favor of MIMO, massive MIMO, and then GIGA MIMO, and others that are kind of more defensive about it. They're like, well, it's expensive, it's complicated, and whatever. So why don't you tell us, how did you come across MIMO from the beginning, and what's the history of the MIMO introduction,
Oh,
the way of thinking that there is more than just one antenna that you can use, basically, right?
yeah. That that is a really interesting journey for myself, even. I mean, it was about 10 years ago when I got my hands for the first time on MIMO and massive MIMO. I was amazed by the very interesting story of the gentleman who invented the technology MIMO in the first place. It was probably 1991 or 1992 when the Indian scientist who immigrated to the US, who's by the name Arjaswamy Paraj, he invented MIMO and he tried to introduce this to a TV broadcasting industry. He tried to bring this to the cellular network industry. Most of people treated him like a liar, and they thought this technology could not be real. It's like snake oil. So it was only him and maybe with some of his students in the university. They are trying to convince people this is real. This could be transformative. Uh, and then I read a little bit more into the details that part of the reasons that people don't really believe him uh, were that first, the software was not there. Second, the hardware, especially the chips, the hardware processing capabilities were not there. So it took some years, maybe in late 1990s, the industry started to see that there are truly some technologies that they can commercialize to make this happen. And then again, a few years later, maybe around 2006, something like that, another scientist, Bell Labs, called Thomas Marzetta. He came up with this idea, massive MIMO. And again, some kind of doubts and wide suspicion about this new technology. But here we are. We have MIMO. For example, in our home, we use Wi-Fi routers with multiple antennas thanks to MIMO. And we have our 5G smartphones, we have iPads, we have a lot of mobile devices that are enjoying the benefits of mass MIMO as well. So
Yeah, absolutely. And
here we
it
are.
actually started with Wi-Fi at the beginning. I mean, sort of big commercialization, at least in the US. Uh, but eventually it just like now MIMO is a pretty much accepted concept. But it did take time. But I guess because people thought, you look at it and it just seems like it's a free lunch. It's like, well, it's just the benefit is so big that you just think there must be something behind it, right? So but that it seems like every time you go one step further, there is the same kind of like it cannot be true. And so maybe just to get back to the sort of the present and the future. So we got MIMO and finally got accepted. Then we got massive MIMO, and it's in many countries that's the standard, especially in dense locations. But then there is GIGA MIMO. So maybe you can tell us how do you go from one to the other?
Oh, well, first of all, we go from no MIMO at all to MIMO is to use multiple antennas between the between the transmitter and the receiver to either increase the reliability of the communication channels or just double or triple or just to increase the capacity of the data transmission between the two. And then later, MIMO was so successful actually that it became a little bit limited in its capability to accommodate the very fast growing of the data consumption thanks to smartphone, mobile internet, and all that. And then massive MIMO is something that can um, improve the performance of MIMO by breaking down the antennas and all that into smaller pieces so that they can control independently to have better performance and lower power consumption or higher power consumption efficiency and all that. But now we're using massive MIMO as a standard feature of 5G network. But even that would be not sufficient in the future, but maybe not for all the places wherever we go, but for those very high traffic areas like in a stadium or something like that. And then the natural logic is to scale massive MIMO up even further. But there's limitation for what you can do with just one form factor or just one radio on top of a cell tower. It's limited. And the power consumption and the other technology limitations are there. So you can further improve the scale of the massive MIMO, but there's limitations. So maybe we can find another way is to do distributed massive MIMO. That is kind of like um, when you're like talking to a group of people on the other side of communication channel, um, you're trying to talk to the other side uh, by yourself. But if you have multiple people that are talking to the other side through different channels at the same time, using different languages or different channels, but all for the same purpose. So the connective efficiency or capacity of the entire system is much higher than using just one people talking at one time. So this is basically, I believe, where M-MIMO would lead us to.
Yeah, and actually, this is another idea that actually started at China Mobile, I think, right? That was a long time ago. The no cells idea that was also at the beginning taken with a little bit of I wouldn't say suspicion, but people say no, it's not going to work. It's not, because basically it challenges. So MIMO challenges the fact that you can have more than one antenna. But this is a second challenge because you can have not only multiple antenna, but the idea of a cell site as a standalone thing breaks down. So you have all those cell sites working with each other, right? So it's another conceptually very interesting development.
Yeah, it took us, or it took the entire world almost 10 years from the conceptual idea of M-MIMO from Thomas Mazzetta to the commercial realization by ZTE to introduce M-MIMO to 4G network. And remember, China Mobile was the first operator to test it in their network and to actually use it. Um, I remember a lot of people were blown away. This is real. It was crazy, but it's a happy surprise.
Yeah, but then let's go back to the issue of the complexity and because as you mentioned, the more antennas you have, the more antennas you have to manage, so the complexity goes up, the costs go up. It's inevitable, and so the question is it worth it, and how should we look at the sort of reliability aspects of it? So how should we because clearly the simpler the system, the more basically easy, reliable, and cheaper, but then you don't get the benefits, the performance benefits, the capacity. So how should we think about that? And as I say, you want to look also from the point of view of the users and the different use cases.
Yeah, exactly. The technologies are getting more complex most of the time. Um, if it's just generational iteration in a general sense, then the cost would go higher. Uh, and this is justified by the driving force of the demand. If the demands are so high that this is economically uh, acceptable or even profitable to do it, because there's no way that you could accommodate the fast growing mobile internet when a lot of the radio sites are congested and people just don't get their social media messages are being sent out, then maybe this is only way to increase the capacity per base station or per cell tower, I would say. There are other ways, of course. We could have more cell towers without introducing MIMO or massive MIMOs, those kind of things. But the other ways, they are more expensive actually. So the least more expensive one is the optimal one to begin with. But there's limitation, of course, because of engineering limitations of electronics and software and all that. But in the long run, I would say the increased complexity will always be justified by the actual growing demands. Without that, it's just more like a experimentation or scientific research. But with the demands, then it's totally reasonable to go ahead with this kind of technologies. I guess this is also related to sometimes people are asking the questions about, do we really need 6G? I think this is actually very relevant to massive MIMO and its generational iteration for the future network, because the answer is probably not for every place or for everyone, because the increasing diversity of the apps, of the terminals that we're using is no longer just messaging or video streaming or just smartphone. We have a lot of different apps. We have a lot of new terminals. That means the diversity of the demands will be really big across entire network. So we don't actually expect you have just one technology to meet all the demands. So that would mean we would have a lot of new ways to offer even higher capacity, while reasonably we would have about the same level of traffic demand on the other parts of the network.
Absolutely. And I think that you make an incredibly important point, especially when it comes to 6G, but we had the same debate with 5G. And in fact, it's also with 4G, is that a technology is not good or bad for everything. Technology is only good for where you need it. It's good to have the option to decide where to use it, but it doesn't mean that you have to have it everywhere. So, 6G, GIGA MIMO, you name it. It's not, you might not need it. Well, you're not going to need it in a highly rural area, but in a stadium, it's a different business. So you really need to look at what is that you have, how much spectrum you have, how many subscribers you have, what kind of devices you have, what kind of services. And then you pick the technology you need rather than the other way around. And so, but I guess that there is still a question of, how quickly do you go to the, so, okay, let me step back. The further on there's going to be more complexity, but at which point should you go for the additional complexity, or do you wait and see what other people are doing, make sure they get everything out, and then you go for it? And how should we think about in that context about the reliability? Because it's not just capacity, it's also, so is there a trade-off between capacity and then reliability?
Oh, yeah, I totally agree. This is a very, very critical point, because with the increased complexity of the MIMO technology or the cellular network technology in general, it also has this increased cost and also reduced marginal benefits if you go further away from the cell tower. I mean, the difference of the end user experience would be greater because we're going probably higher spectrum bands, or we have high power from the radio. Then you cannot always maintain the same capacity or the user experience uh, across different distance to the cell tower. I mean, the reliability of the end user experience has to be guaranteed somewhat to make sure you're not seeing a 4K video on YouTube when you're close to a cell tower, but when you're away from it to the cell edge, you would have to live with maybe some kind of quality 10 years ago. So that is bad for business.
Mm-hmm. Yeah. Well, although sometimes that's still the experience. I'm in London right now, and I was in Shanghai like a month or so ago, and clearly the kind of expectations and reliability of service there is different than here. So sometimes you don't get anything, especially if you go like in the underground in some you know other environments. And I guess that there is again also a question of what are the expectations from the people out there. So if I know that when I go in the underground here there is no signal, I prepare myself. So if I have to go somewhere, I make sure I have all my directions before I go underground. When I was in Shanghai, that was not really a thought I had. You just like, well, whenever I'm in there and I'm sitting down on the train, I'll figure it out. So I guess that there is a lot of, what are the expectations of the people? Which is, going back to your point, we should really think about what people do expect, and what people do expect is somewhat driven from what they already have. So you can go backwards, but how should we think about that? In terms of, obviously people want to have the best experience, but if they're used not to have the best experience, maybe they're just fine with it because they don't know better.
Exactly. So this is another driving force behind the technology developments to enhance particularly the user experience or network capacity when the users are really away from a strong coverage point like cell tower. You mentioned underground, which is a very typical place. People would get themselves ready to lower their expectations about the network speed or user experience. But there are a lot of places that they don't really uh, aware that these places are going to be bad. There's no metro or tube or underground sign at the entrance. But in fact, there may be just going away from cell tower and they had no idea. So in those cases, if they don't get themselves prepared, their expectations would still be high. So what the network can do is to give them better support. In a lot of cases, you're moving away from the cell tower, and that would increase the chances that you're receiving the signal from the other cell towers from another place. So in that case, if somehow we can consolidate all those signals together to strengthen each of signal, then you would have better speed, have better user experience. That is actually what distributed massive MIMO about, because it's actually turning those either not related signals from multiple sides or turning even interference into useful signals. So by doing that, we could improve the cell edge user experience, not on par with those guys near the cell tower, but not too different. So that should be good for everybody.
Yeah, and that's actually very interesting because you just again you think of the network as a sort of fabric rather than the sort of one cell side with handoff to the next cell side, so on and so forth, which is kind of a little bit of a clunky system. So it's a way you can manage. You know where people are, you know what your network resources are, and you find the best match. And so that basically, it just seems like it introduces the kind of effectively introduces redundancy, and that has to be a huge effect on reliability, which it's very important because capacity is important, but if you don't have reliability, then the capacity kind of gets washed away sometimes because you just have a very uneven experience. So I would argue that it's important from a user point of view to have a good experience. It's important, but it's also very important or equally important to have a sort of reliable experience through time. So the connection might go down or whatever, in some places it might not work, but it's actually good to have it that you know you can trust it. So one thing that I think it's really important, if we look at from the user point of view, it's clearly that they want to have the best experience possible, and that requires capacity. However, it's also true if that capacity massively goes up and down, you have a kind of weird experience because you don't have the reliability. And this is exactly what being able to have a network where you have not just individual users, individual devices, and individual towers, but you have a set of users that are sharing the resources, and you can allocate resources regardless of the cell tower location. It's much more efficient and increases the reliability, and that's really just as I would argue just as important, because not only you have a good experience, but you have an experience you can rely on and trust. So how should we think about this sort of trade-off between the capacity and the reliability and basically redundancy in some cases? Because you'd be talking to two different, I mean, your device would be talking to two different cell sites.
Yeah, that's a really important point. I would say in some cases, the capacity and the reliability, they are a trade-off. But in some other cases, they don't have to be a trade-off. We can turn capacity into reliability. And that's possible. Let me explain. Um, in some cases, if you're trying to maximize the capacity, and then the reliability would be an issue because resources are limited, and you're putting the majority or even all the resources for the maximized capacity, then the reliability will be, the something that is being sacrificed. But when you're, let me take example from the drones. Uh, my my colleague the other day told me about her experience using drones. He recently bought a drone and just for fun, for 5 minutes. And in the beginning, did not, she did not buy a cellular module for the drone. He thought Wi-Fi should be enough because most of the drones are basically working on the Wi-Fi spectrum. But he soon realized the maximum distance she could use, the video streaming and control of the drone to up to just 1 kilometer. Beyond that, you cannot have the videos. So later, she bought this, 4G module to put into the drone, and voila! Now she can do maybe 6 kilometers, 8 kilometers without worrying and about losing the control visually, and it is a great help. But imagine we're using a very busy cellular network, 5G, or even in future 6G. A lot of drone users or other users, they are actually expecting a very stable video quality for the drones or other uh, stuff. Then it's changing a lot. You would not be happy. For 1 minute, you could see all the details nice and easy. And the second, uh, you see very poor quality. So that is very bad. So in that, we can turn into the capacity of maybe a group of neighboring cells for the same drone to have better reliability. So that is what I mean by turning capacity into reliability. So the end user experience is more reliable. Uh, and the other cases would be more for critical missions. Then you would expect not extremely high bandwidth, but you're expecting more reliable multiple channels of data receiving at the same time. So you don't lose the connection, um, no matter where you are. So in that case, the reliability is about the connectivity. So M-MIMO can actually also do that because it can give you very precise beams to make sure that the connectivity or direction of the signal is always precise. Uh, but this is not so much about capacity, but about the, I would say, capability to support really good reliability.
Yeah, and I think that that's an important difference in the sense that you are not over provisioning the network because the amount of spectrum is the same. You just become more efficient in how you use it. So actually, somebody talked about like the perceived capacity or perceived performance, whatever, which is actually in a way it's a useful way to think about it. It's not so much the overall capacity in the network, which might increase, but it's the perceived capacity from the end user point of view. Is how good is your video? So it's more about being more efficient, and that's what MIMO does. Is it allows you to be more efficient because whatever resources you have, you use them in a more specific, more targeted way. So instead of having the capacity sitting there, you actually use it because effectively, if you can use multiple cells and split them up multiple cells, it means that you have less unused capacity in the network. So it's not just
Exactly.
you're not just adding capacity, it's using it better.
That's
And
right.
that, yeah.
Exactly. People are talking about, for example, spectral efficiency all the time. They say the spectrum resources are so expensive. We have to maximize the money we create out of it. But if you compare the theoretical spectral efficiency with the actual efficiency of the cellular network, the difference is huge.
Yeah.
Sometimes it's so huge that you would wonder where the capacity goes. So it's about utilizing the capacity to its maximum. For example, the traditional way of scheduling radio resources are sometimes based on some thresholds. That it basically says if a user is not receiving radio signal that is bad enough, then the network doesn't have to do anything.
Mm-hmm.
But that doesn't differentiate the user demands or requirements on the network based on the apps or the services that they're using. So the new way or the better way is to actually to give them enough resources when they need it, not because their signal quality is bad.
Mm-hmm.
It's just because they need a better resources scheduling. So that's a better way to do it.
Yeah. Yeah. And I think that
So
that's
this is
it
about
makes us
addressing that.
yeah, and this is an absolutely important point because it makes you look at the network, and this is not just marketing talk. It's a real performance talk to look at the performance from the point of view of the user rather than from the point of view of the network. So, and we've been talking about, paying more attention to the user, but this is more than just saying paying attention to the user because otherwise they complain or otherwise they don't pay or they churn. It's really it's a kind of a more basic kind of thing is to measure how good the network is. It's not how much capacity you have in theory, is how well that capacity is being used. I mean, obviously you need to have capacity, but other things being equal, it's not just having capacity is not quite enough. You need to use it efficiently. Otherwise, it's like the tree in the forest that falls, but nobody hears it. It sits there.
Yeah, exactly. The results are beneficial to both sides. The
Mhm.
users are happier, and the network operators are utilizing their precious assets more efficiently. So it's good for both.
Yeah. Okay. So our time is up, but when I ask you, final questions to sort of distill what we've been talking so far. So we've gone from one antenna to over 250 antennas. Now that's sounds like the next thing. What do you see coming next, and what is going to be really the major change? And don't say 6G. We know that 6G is coming, but from a massive MIMO in general, in the MIMO world, what's coming next?
First of all, I think if we're not going to other spectrum resources, we're just using the spectrum resources we have today, or having the same kind of network architecture today, uh, everything is staying the same. Uh, what can we do? We need to actually to improve the spectral efficiency. Actually, we're squeezing more juice out of the existing resources. But happily, we're not in that situation. So apart from increasing the efficiency of utilizing those the spectrum resources, we are going to maybe enjoying new spectrum bands, which is both good news and bad news. The good news is the capacity is always about, first of all, the pipeline being really, really big.
Mhm.
That is even more important than the spectral efficiency. So new spectrum means new pipeline. But the bad news is there would be even greater challenge in a few different ways. The first is the challenge would be how we make sure the more higher spectrum bands would be having a reasonable coverage range without increasing the expensive infrastructure investment too much. So there's a trade-off. The second challenge is about engineering implementation. You put so many different spectrum bands on the same cell tower. Naturally, it would mean introducing more radio devices, more baseband processing power inside the radio side, and all that. So the increased complexity would only be solved with the advancements of the chip technology, of the software algorithm, or even with the help of AI. Not necessarily large language model AI, but AI in general. So all of these things putting together along with the hardware innovations, such as the structural design to make those, hardware more efficiently. Uh, so this is the second challenge, and the third challenge would be actually to find the most, I would say, proper use cases to actually to connect the technology innovation and product commercialization with the actual demands or use cases. We're not going to waste the technology innovations or product developments on those less promising use cases, but to find the perfect match. I think that is even more challenging than the pure technology challenges.
I
But
absolutely agree. Yeah, and I think that we need to be kind of realistic in what those use cases are, because it's very easy to think there is a use case, but then effectively that use case might be there, but it's far out in time, or there's not enough demand or willing people willing to pay for it. So we need to be very careful. But said that, that shouldn't stop the technology development, but we need to really be more careful about not overestimating it, because otherwise we run into trouble. We sort of over deploy, and then so. But sorry, you were saying something.
yeah, I totally agree. I think um, sometimes uh, this is something beyond the even the wildest imagination of the industry,
Mm-hmm.
where the next big thing, I mean, regarding the advance, would come. We don't know for sure. We didn't expect smartphone would be that popular to
Mm-hmm.
give so much a push of the demands on the mobile internet. We didn't know that. And it was out of blue, and it was a happy surprise. And now we're kind of, conservative or not that optimistic about the next big thing. But who knows? Myself is, I would say, cautiously optimistic because we don't know for sure. But there are some exciting developments that are coming, like augmented reality glasses
Mm-hmm.
or brand new forms of AI devices, not powered by AI, but with AI as the center of devices. We don't know for sure when they would come and how big penetration rate they would get within, let's say, just 1 year of introduction. But I would say there are hopes, and the diversity it would increase, not decrease, across the entire ecosystem and landscape of those apps, terminals, and services would mean that the demands are not universal, but more use case specific or scenario specific. And I would think that would be why we need this kind of MIMO or massive MIMO or GIGA MIMO developments.
Yeah,
So
absolutely. No, yeah.
cautiously
Yeah,
optimistic.
and I think that it's really important that you match the sort of the flexibility and complex. So technology gets more complex, okay, but then you have the flexibility to use the complexity where it helps you, which is based on the use cases. So I think it's both. Anyway, Zhang Jiong, thank you so much for sharing your thoughts, and it was a great conversation. We talked about pretty much everything on MIMO, up and down, deep and on the surface. So it was great talking to you.
It's such a great pleasure. Thank you so much.
And thank you all for listening. And do continue to listen to Sparring Partners, and let others know as well about it. Thank you so much.